This is a pretty disgusting integral, but we can make things really easy with u substitution. We're going to say u equals e to the x squared plus 2. When we take the derivative of e to the x squared plus 2, we get du equals e to the x squared, and then the chain rule says you got to take the derivative of that inside function. The inside function is x squared, so we say times 2x dx at the very end of that. I'm going to solve for dx here. This just means I need to divide by e to the x squared and 2x, so I have du divided by 2x e to the x squared. Now that I have all this, I'm going to substitute it in over here. I have the integral of x e to the x squared over the square root of now u. Remember, e to the x squared plus 2, that was our choice for u, and dx gets replaced by du divided by 2x e to the x squared, which is really convenient because this e to the x squared cancels and this x cancels, leaving me with just du. We'll put a 1/2 out in front. That 2 can come outside, and so we'll divide by square root of u. All right, before I integrate this guy, I'm going to actually write this as 1/2 integral of u to the negative 1/2, so I can apply that reverse power rule. When I add 1 to the power and divide by the new power, I end up getting 1/2 times u to the 1/2 divided by a 1/2. To divide by 1/2 is the same as multiplying by 2, so that 2 will cancel with that 1/2, and so I just have u to the 1/2 as my answer. Make sure you back substitute though. We're going to go and back substitute e to the x squared plus 2, so I get e to the x squared plus 2. This is all being square rooted because of that power of 1/2. And don't forget, I'm evaluating this from 0 to square root of ln of 3. When I plug in that upper bound of the square root of ln of 3, square root of ln of 3 squared is ln of 3, and e to the ln of 3 just cancels, giving me 3 plus 2 would be 5, and so I have square root of 5 as my first term. Then I plug in 0 as my lower bound. 0 squared is 0, e to the 0 is 1, plus 2 is 3, so I have minus square root of 3, and that is my final answer.